Okay, welcome out there, ladies and gentlemen. This is 4.5, last section from chapter 4. We're going to continue our study of conic sections, and in this particular case, we are looking at translations. So we're going to be moving things left, right, up, and down. We're going to be looking at this HK down here. This is the new center or the new vertex for parabolas, new center for the ellipse and the hyperbola. You might remember things for HK like we did with the vertex form of a quadratic and completing the square. That's something we need to do today. So for the most part, everything follows exactly like what we did in the last lesson, only the equation is going to change ever so slightly. So for the case of a parabola, the three pictures that I have here today are actually the ones from the textbook, so they actually gave everything that I needed to know in this. In order to move my vertex to a new HK, when it opens up or down, the transformation looks like this. It's x minus h squared equals 4p, just like we did before, times y minus k. And then you'll notice the focus point is at the h value, and then k plus or minus p, depending on if it opens up or down. Notice this is when p is bigger than 0. If p is less than 0, then it would open down, and it would be k minus p. Over here on the right-hand side, this is for when it opens right or left. And notice it gives us everything we need to know. The vertex is HK. The focal point is P units from the vertex. And the equation looks like y minus k squared equals 4p times x minus h. So you'll notice that the h always goes with the x, and the k always goes with the y. And that should make sense since it's h comma k, which is x comma y. All right, and then obviously the directrix goes on the opposite side of the parabola itself. Okay, that's the parabola. Let's look at the ellipse. Same kind of thing, moving the center to a new point. So this is the center HK. And what we'll notice here, the one on the left, is a short, fat ellipse. So remember the a squared goes underneath that x because it's short and fat. On the other one, a squared goes underneath the y because it's tall and skinny. Something that this particular picture does not add in here is the c value for the focal points. This distance right here is... or not that distance is c, it's always c, but that point, or the 2 points, are going to be h plus and minus c, comma, k. And then the vertices, going out to the a value here, so this is a, or a distance of A, the vertices are going to be H plus or minus A, comma, K. So that's to find the vertices. And this over here is to find the foci. And then likewise over here, it's a little bit different. Instead of changing the x values, moving left and right, we need to change the y values. So let's call this my c, the distance of c. So in order to find this, in order to find the coordinate themselves, it is h, comma, k, plus or minus c. That's to find the foci. And to go to the distance here, this is h, comma, k, plus or minus a. And then it actually kind of goes along with the hyperbola as well, but we'll get there in just a second. All right, so big important thing is the change in my equations. And obviously this works if the center was 0, 0. We would just go back to like the previous lessons thing. So h is 0, k is 0. We just get the normal equation. All right, moving to the hyperbola. Same kind of thing. Same kind of idea here. My vertices are still a units from the center, and my focal point is still c units from the center. Everything that I told you in the last lesson still applies. All right, so in this case, on the one on the right, because y comes first, it opens up and down. On the other one, because x comes first, it opens left and right. The distance from center to vertex is still a, and the distance from center to focus point is still c. It's just obviously now our center moves around. Okay, so now let's get to the big piece from today. That's just kind of a minor change. Now we need to move to the piece that everybody kind of gets frustrated at, and that's completing the square. So we're going to start with a basic one from one of the previous chapters where we did completing the square. And we're going to look at this particular problem. And I want to put this in completed square form. So I'm going to kind of model this particular equation exactly how we're going to model it in today's stuff. So what I want to do is I want to add 9 to both sides. And I'm going to do my little plus blank, as you probably know that I do. And because I'm adding to one side of the equation, I need to add to the other side as well. And then you have to remember that the number that goes in here is the square of half of b. So b over 2 squared. And in this case, it's 4 over 2 squared, which in this case is 4. And if you look at our equation now, we have x squared plus 4x plus 4. And that factors nicely to x plus 2 squared equals to 13. Now, I know that's not exactly how we wrote our completed square or vertex form for quadratics, but we're going to kind of leave it like this. I'll show you what we're going to do with this 13 in a little bit. Okay, so that's that kind of case. That's where a is 1. The numbers are a lot nicer, a little bit easier to deal with. What if a wasn't 1? I'm going to look at an example like that. In this case, 2x squared plus 6x plus 5 equals 0. And I hope you're telling yourself, oh, you have to factor out this 2. Well, you do. But, here we go here, plus blank. I don't want to do it to the 5. I'm actually going to minus the 5 to the other side. And again, I'm going to do my plus blank, because this actually is a plus, because that 2 is positive. Now I need to take half of 3, and I square it. And if I take half of 3 squared, I get 9 over 4. But then you have to do the little tricky things that we did in the last chapter was, okay, that's actually x squared plus 3x, and oops, let me get rid of that. It's just a second here. I'm going to do this a little bit different here. Because this 2 actually goes times the 9/4, I have to do 2 times 9/4 to get this number here. And in that case, it's going to be 9/2. And so I get 2 times x plus 3/2 squared equals, this is 4.5. So -5 plus 4.5 is -0.5, or -1/2. And for us, that's okay for today. We're not going to get negatives in our work for the lesson today, but that's kind of how we would work this one. All right, so let's look at what we're going to look at today. It gets a lot more complex because we need to write the equation of the conic in standard form, and this is the equation that you're going to be getting. You're going to get something big and kind of ugly just like this that you're going to need to be able to write in standard form, either a parabola or an ellipse or a hyperbola. I think this particular one ends up being a circle if I remember correctly, but we'll get to there in just a second. So what we want to do here is we want to get all of our x's together and then all of our y's together and get the number on the other side. So I'm going to start with x squared minus 6x. And because the x has to be a piece squared, it's my plus blank. Plus y squared plus 4y. And again, I have to do this here, and I get -9 plus blank plus blank. Now, some of you are like, what is he doing? Well, here's what I'm doing. I'm completing the square for the x's, and then I'm completing the squares for the y's. And because I'm adding 2 different numbers here in these 2 blanks, I need to add 2 numbers on the other side. So if you follow the last page, I have to take half of 6 and square it. Half of 6 is 3, squared is 9. And I don't care if that's a minus, it's always plus. Well, if I added 9 there, I have to add 9 here. All right, the other one, half of 4 squared. So half of 4 is 2, squared is 4. And since I added 4 here, I have to add 4 here. And you're almost done. In this particular case, I would get x minus 3 squared plus y plus 2 squared, sorry for the ugly writing today, equals -9 plus 9 is 0, plus 4 is 4. Now, some of you might know what this equation is right away, but if I was to divide both sides by 4, I would get x minus 3 squared plus y plus 2 squared equals 1. Don't forget the over 4 here. And some of you might look at this going, but the numbers are the same in the denominator, and you're right. And that becomes a problem for the 3 conic sections that we've dealt with yesterday. Well, in this particular case, since the numbers are the same, this is actually a circle with the center. Hope you're following along at the beginning of the PowerPoint. The center is, well, whatever makes this 0 for the x, so 3, and whatever makes this 0 for the y, -2. And my radius, because it's a circle, is the square root of 4, which is 2. I don't think I assigned any circles in tonight's lesson, or in today's lesson, but that's what a circle would look like. And we're going to do the same thing again for another problem that hopefully comes out with an ellipse. All right, so another big, ugly looking thing, right? So first step. Let me get rid of that 1 there. X squared minus 6x plus blank plus 4y squared plus 16y plus blank equals negative 21. So there's a 4 in front of this y squared, which means I need to get rid of that, which means I need to factor it out. So before I can do anything, I need to do 4 times y squared plus 4y plus blank. And I just got to bring this x stuff along for the ride. And I got a negative 21. I forgot my 2 plus blanks that I have to do. Well, same process. Half of 6 squared is 9. So because I'm adding 9 here, I have to add 9 here. Half of 4 squared is 4. And here's where you got to be very, very careful. It's not a 4 over here in this other blank. You actually have to do 4 times 4 because you actually added a 16. That's what the number would go up in this blank up at the top. So there would be a 16. Then I can factor. I get x minus 3 squared, just like before, plus 4 times y plus 2 squared equals, well, negative 21 plus 25 is 4. And because all of our equations have a 1 on the equal side, we have to divide everything by 4. So we get x minus 3 squared over 4 plus, here I'm divided by 4, but 4 divided by 4 is 1. So I'm going to write this as oops, not y squared, y plus 2 squared. I am going to write over 1 just because for right now, even though technically you don't need to. And here we have an equation. And you might be wondering, what's the equation of? Well, I'm glad you asked because it's something we need to know. Because it's a plus sign, it tells me that it's an ellipse. Okay? Tells me that it's an ellipse automatically. Again, if you're paying attention at the beginning of this particular lesson, the vertex, or the center, sorry, is going to be whatever makes the x 0. So 3, comma, whatever makes the y 0, negative 2. And you can find all sorts of things. Because the bigger number is under the x, it's a short fat. If I wanted to find my vertices, I need to use the a value. Well, the a value is 2 because it tells me that a squared is 4, so therefore a is 2. Now, here's where I like to sketch things out, folks. This is the point 3, negative 2, the center. And it's a short fat because it's the x version. So my vertices are going to be a units from the center. So it's going to be a units to the right and a units to the left. So I have vertices that are going to change the x values here. So it's going to be 3 plus 2, which is 5. And 3 minus 2, which is 1. So there I have 2 vertices. They're both different. Don't just do plus minus, because that's not the case anymore. I could then find my foci if I needed to, because I needed to find C value. If I needed to find C and figure out my foci. And And that's all we need to know. This is my equation right here. It'll probably ask you to find what's the equation of. It'll say what's the center, what's the vertex. If it's a parabola, it might ask you what's the directrix and the focal point and the vertex. But it all comes from completing the square. So I have one more. It's actually, in this case, it's a parabola. And you should be able to know it's a parabola right away. Actually, there's different ways you can think about these. You know it's a parabola here because it's only got one quadratic term. And the other two here, you should know they're either ellipses or circles because it's an x squared plus y squared or an x squared plus y squared here. All right, so for parabolas, the ones that look like this, we want to do y squared minus 4y. And here's where it changes from the other two equations. We want to plus blank. And our equations for parabolas have the quadratic piece on one side and the linear piece on the other. So I just want to do it this way. So if I get half of 4 squared, which is 4, I need to add 4 to both sides. I'm going to factor the left now. And I do actually want to factor the right-hand side because we need an x minus h. So in this case, it's kind of nice because I can factor out the 4 out of both. And there we go. There we have a parabola. Our parabola has a vertex at -1. And here's, I'm going to actually write this because some people are going to mess this up. It's not whatever comes first. It's the x that comes first. So it's -1, comma, 2. That's my vertex. Be very careful here. It's one of the most common misconceptions here. They just go with the first number, the second number. All right, be careful. All right, so that should finish me up. So Tuesday, tomorrow, that would be tomorrow for you guys actually watching this when you're supposed to. Page 368, there are seven problems due to me. Wednesday, Thursday, depending on which class you are, 4th period, 6th period, we're going to do a review. We're just going to kind of start our chapter review and review some of our conic sections, that sort of stuff. And that way I put the quiz on Friday, so I don't have to remember who took what. And then Tuesday before Thanksgiving, the week of Thanksgiving there, Tuesday is going to be our chapter test. So start studying up, and I will see you guys tomorrow.